Hey there, algebra students. Welcome to our mid-chapter review for chapter 6. This chapter is all about systems of equations. So that's what we're going to review today. Now, so far in this chapter, we have learned 3 methods for solving our systems. The first is graphing. We graph the 2 lines to visually see where they intersect. Step number 2, substitution. This is where we solve for one variable and then substitute it in for the other, to solve for the other. And number 3 is elimination. So this video is going to go over these 3 skills. Let's start with graphing. So our first system that we're given is 2x plus 3y equals negative 12, or equals 12, and 2x minus y equals 4. Now, step number 1 when solving a system by graphing is we want to put it into y equals mx plus b form so we can more easily and accurately graph it. So when I'm solving 2x plus 3y equals 12, I want to solve for y. And then I'm going to do the same thing for my second equation, 2x minus y equals 4. So let's start over here. We're going to first subtract 2x from both sides. That gives us 3y equals negative 2x plus 12. Now we're going to divide both sides by 3. That cancels it out and gets the y alone like we were trying to do. But remember, when you divide by 3, you're dividing both terms on this side of the equation. So this becomes negative 2/3 x, and this becomes plus 4. Now the next equation, 2x minus y equals 4. So we'll start by moving the 2x by subtracting. So we get negative y equals negative 2x plus 4. And then we need the y alone. Now this negative sign is really a negative 1 as our coefficient. So to get the y alone, we're going to divide by negative 1 on both sides. So y equals 2x minus 4. Now we have our 2 equations. The next step is to graph them so we can see where they intersect. So we'll start with y equals negative 2/3 x plus 4. The plus 4 is my y-intercept, so I'm going to go up to positive 4. And then my slope is negative 2/3. So if my slope is negative 2/3 x, that means I'm going down 2 and to the right 3. So I'm going to go up to my y-intercept, that's my starting point, and I'll go down 2 to the right 3. And I'm going to continue that slope across the entirety of my coordinate plane, because especially with systems, it's very important that our line is accurate so we get an accurate solution. Now, I've extended it all the way this way, but I don't know yet if my solution will be up here or down here, so I need to really make sure that I extend it both directions. So that means I'm going to do the opposite of what my original slope was, because if I do the opposite, it's still continuing technically the same slope. So this will be up to the left 3. So I'm going to go up to the left 3. And just continue that until I can't anymore. Now I have all of my points, so I can connect the dots. And I have my first line. Now, it's not a system unless there's more than one equation, and we don't know a solution until we see where that system intersects. So we have to graph the second line, y equals 2x minus 4. So we're going to go down to negative 4, that's our y-intercept, and our slope is 2x. So that slope means we're going to go up 2, because it's a positive slope, and to the right 1. So up 2 to the right 1, up 2 to the right 1, and we'll just continue that slope all the way. And then I'm going to continue it the other direction, down 2, and to the left 1. Down 2, to the left 1. Now I'm going to connect those dots carefully. Whoops, a little off center there. And see where those lines intersect. They intersect right here, which makes this point the solution. So step number 3, name the solution. And no, I don't mean name it Bob. We're going to name it as an ordered pair because our solution is the point where the lines intersect. So we need an ordered pair to represent where that point is. So for this system, it's at positive 3. So we went over 3, up 2. So positive 3, positive 2. That's my solution for this system. Now let's do another one. Again, graphing. This time we have y equals negative 5x minus 7 and y equals negative 1/3 x plus 7. Now in this system, they've given us both equations in slope-intercept form already, which is wonderful. Love it when they do that. So I don't have to solve for y. It's already been done for me. So I'm going to start by just graphing. This equation, my y-intercept is negative 7. So I'll go down to negative 7. And then my slope is negative 5x. So negative 5 means I'm going to go down 5. And then I still go to the right 1. But if you look, my y-intercept is already on the negative side. So I don't really have space on this graph to continue going negative. So I'm going to take the opposite of my slope. Instead of down 5 to the right 1, I will go up 5 and make sure I go now to the left 1. Because this negative slope, I still want my line going downward, forming that N that we've talked about. So I'm going to go up 5, 1, 2, 3, 4, 5, to the left 1. And I'll just continue that all the way up until I can't anymore. And then I'm going to connect the line, or connect the dots to make the line. All right, now I'm going to graph the second equation in the system. This one has a slope, or a y-intercept of positive 7. So I'm going to go up to positive 7. And now my slope for this one is negative 1/3 x. So that's down 1 to the right 3. Down 1 to the right 3. 1 to the right 3. Down 1 to the right 3. Now I've run out of space going this way, but I haven't quite found my solution yet. So I'm going to do the opposite, which is up 1 to the left 3. Up 1 to the left 3. Up 1 to the left 3. Now when I connect those points, I now can see where my solution is. It's right here. So that would be negative 1, 2, 3, and then up 8. Negative 3, 8. And that would be my solution. All right, so that's graphing to solve our systems. Now let's try elimination. Now, when we're eliminating, we want to try and cancel out one of our variables. So all that's left is the other one. So for elimination, step number 1, we want to line up our like terms. So we look and make sure the x's are aligned, the y's, the constants. And this one already is somewhat, but the way the computer printed it out, it's a little off kilter. So I want to make sure it's truly lined up just so I don't throw myself off or leave myself room to make any silly mistakes. So negative 2x plus 3y equals 5. and 5x minus 3y equals negative 8. Now, step number 2, after we've lined up our like terms, because we already have to decide, are we going to add or subtract our two equations to eliminate one of those variables? Add or subtract. So here, negative 2x and 5x, they don't have the same coefficient, so those won't eliminate as is. But 3y and 3y, those are the same coefficient. But now to decide if they are going to need to be added or subtracted, we look at the signs in front of them, plus or minus, or in this case, I'm going to look at it as positive and negative. Now, positive and negative already cancels out. So when our signs are opposites, we can just add the two equations because they're already set up to eliminate. Now, if they were the same sign, they wouldn't eliminate. They would combine to create a larger or smaller, if it's a negative, number. So that would be when we subtract. But here they're opposite signs, so we're going to add, and we're going to add all three terms in the equation. So negative 2x plus 5x is 3x. 3 minus 3 cancels out. Bring down the equal sign, and 5 minus 8 is negative 3. So then we want x alone because that's all that's left. So we want to solve for x, and we get x equals negative 1. Now that we've solved for one variable, then we are now going to substitute that answer in to find the other variable. So we solved for x, so I'm going to pick one of these equations. I'm going to use 5x minus 3y equals negative 8. It can be either one. They will both give you the same answer if you do the steps correctly. So I'm going to take the answer I have, which is the value for x, and I'm going to plug it in to x. So 5 times negative 1 minus 3y equals negative 8. That becomes negative 5 minus 3y is negative 8. Then I'm going to add 5 to both sides. And we get negative 3y equals negative 8 plus 5, negative 3. Now we want to solve for y, so we'll divide by negative 3 on both sides, and we get y equals negative 3 divided by negative 3 equals positive 1. So our solution for this system would be negative 1, 1. Now, for the sake of this video, we're not going to take the extra time to go back and check it on video, but we would at this point go back and plug in our value for x and our value for y for both equations to make sure that it equals 5, or in this equation, negative 8. On your homework, tests, quizzes, etc., I really highly suggest and would like to see you solving and then checking each system to make sure you get your answer correct, because that's a great way to catch any mistakes before you turn in your paper and get your grade. Okay, so let's move on to the next one with elimination. We have negative 4x minus 5y equals negative 4, and x minus 5y equals 1. So I'm going to line these up. Negative 4x minus 5y equals negative 4. And then x minus 5y equals 1. Now in this system, notice I have both negative 5s. If I were to add these, negative 5 plus negative 5 would be negative 10, and that wouldn't eliminate anything. So this is a case where I'm going to subtract. Now remember, if you're subtracting one term, please remember to subtract all three terms in the equation. So the y's will cancel out. Negative 4x minus x is negative 5x equals negative 4 minus 1, negative 5. Now, don't forget that even over here, you're still subtracting. So sometimes I even go in and like write in the minus sign just so I remember. Now, negative 5x equals negative 5. Divide by negative 5 to get x alone. And x equals 1. Now I'm going to take one of my equations. This one looks like fun. X minus 5y equals 1. And I'm going to plug in 1 for x. Now I'm going to subtract 1 from both sides. Negative 5y equals 0. And then I'm going to divide by negative 5. And I get y equals 0 divided by negative 5 is 0. So y equals 0. Now, whenever I get 0, I get a little suspicious. So I'm just going to go ahead and check these. I'm going to take the time to check them. So the first equation, negative 4x minus 5y equals negative 4. I'm going to plug 1 in for x and 0 in for y. Now that gives me negative 4 minus 0 equals negative 4. Negative 4 equals negative 4. Okay, so my solution works for one equation, but it has to work for both. And sometimes it will work for one, but not for the other. So always check both. So x minus 5y equals 1. So 1 minus 5 times 0 equals 1. 1 minus 0, and that gives me 1 equals 1. So my solution, my final answer is 1, 0. All right, so that's elimination. Now let's use our third method that we've learned, which is substitution. Now with substitution, we're not going to eliminate any variables. We are going to first solve for x or y. It really doesn't matter which variable you start with. It will just depend on what the equations tell you. So looking at my first system, 2x minus 2y equals 4, and x plus 3y equals 10. Now, it's always going to be easiest to isolate a variable that does not have a coefficient. Now here, x is already alone. So I'm going to start with x plus 3y equals 10. And that's the equation I'm going to solve for first. And I'm going to solve for x because it's already almost alone. I'm going to first subtract 3y. And I get x equals negative 3y plus 10. Now, I technically have now gotten myself a value for x. It might not just be a regular number like we would love to have because that would be easier, but it does equal x. So my next step is to take that and plug it into one of my other equations, or one of my equations. It doesn't have to be other. I'm going to plug it into 2x minus 2y equals 4. So x is negative 3y plus 10. So using parentheses are key. I'm going to plug in negative 3y plus 10. There is my substitution. So we solve for x or y, then we substitute. So that's what we just did. After we substitute, we're going to solve. Now, since we substituted our value in for x, that means all that's left are y's. So we're going to be solving for y. First, since I have parentheses, we'll distribute. That becomes negative 6y plus 20 minus 2y equals 4. Then I want to combine any like terms that I have. So negative 6y minus 2y is negative 8y plus 20 equals 4. I want to get y alone, so we'll subtract 20 from both sides. And that gives us negative 8y equals 4 minus 20 is negative 16. Now I'm almost done. I need y alone, so let's divide by negative 8 using those inverse operations. And we get y equals negative 16 divided by negative 8 is positive 2. So y equals positive 2. Now we've solved for y. My next and final step is to substitute y and solve for the other variable, which is x. So if y equals 2, I'm going to take one of my equations. I'm going to use x plus 3y equals 10. And I'm going to substitute my new value for y, which is 2. And then solve for x. So x plus 6 equals 10 minus 6. X equals 4. All right, so we've got our solution, 4, 2. Okie dokie, let's do one more substitution. Now this one, it's the y that does not have a coefficient. So I'm going to start with that equation, negative 3x plus y equals 0. And I'm going to add 3x. That gives me y equals 3x. And I don't have to write it, but it does help me remember that there is a y, I guess, plus 0. I'm not going to continue writing that. It's not necessary, and it's just an extra step for me to write down. So y equals 3x. Now I have my y value. So my next step is to plug it in to one of my equations. So negative 9x plus 3 times 3x equals negative 3. Negative 9x plus 9x equals negative 3. Well, negative 9x plus 9x is 0. So 0 equals negative 3. Well, that is a false statement. So this would be a no solution equation. Now, when I get no solution, I do get a little suspicious just because sometimes if I make a mistake, I could get to a no solution, but it's not correct. So I'm going to just plug in y for the other equation. So negative 3x plus 3x equals 0. So negative 3x plus 3x equals 0. That's 0 equals 0. Ooh, but that one is true. So if that happens, what do we do? Let's go back and double check something. Anything. So we had negative 3x plus y equals 0. We added 3x to both sides, so we got y equals 3x. Then we had negative 9x plus 3y equals negative 3. So if we plug that in, we get negative 9x, 3y. Well, that's now 3 times 3x. So that's 9x equals negative 3. We plug that in, we get 0 equals negative 3. That's false. So I did my steps correctly. When you are identifying no solution, it only takes one equation to be false for it to be a no solution. Sometimes one equation will work. In this case, negative 3x plus 3x equals 0. 0 equals 0 is true, but that's because that was the equation we used to solve for y. So no solution is the correct answer here. Okay, let's move on to our last skill that we're going to practice, and that's going to be word problems. So we are now going to use a system of equations to solve a word problem, a real life situation. Let's start with our first problem. Let's get a little closer for these. There we go. So when we're using a system to solve an equation, we're going to write down the system. Okay, you need to show me a system of equations, meaning two clear linear equations. And then step number 2, we can use any method to solve. If I don't specifically tell you which one, you can use any method, but usually there will be one that kind of presents itself as an easier one. Sometimes there isn't, or sometimes we just have a preference that we like to use more than the other. So use the one you're comfortable with. Now, let's apply these steps to our first word problem. Find the value of two numbers if their sum is 11 and their difference is 1. So they're giving us two values for these two numbers. Now this one's nice and straightforward though, because we're not multiplying or finding the product of the two numbers. There's no 2 times a number in this sentence. So this just means my two numbers are going to be A and B, or X and Y, or W and Z. It does not matter which variables you use in your systems, but I'm going to use A and B. And they first tell me that their sum is 11. So I'm going to add them together and set it equal to 11. And then they tell me that the difference is 1. So my second equation in the system is now A minus B equals 1. Now I've written my system, it's time to solve. Looking at it, I ask myself, do I want to use substitution or elimination? Either one would be fine, but just the way I've happened to line it up, I actually see that it's set up for elimination. So I'm going to add these two equations, and I get 2a equals 12. Divide by 2, and a equals 6. Okay, that worked out pretty well. Now that I have a, I can plug it in. So I'll use a plus b equals 11. So 6 plus b is going to equal 11. Then we subtract 6. We take it away, so b is alone. And we get 11 minus 6 is 5. So b equals 5. Now remember what we talked about. If we have variables that are not our typical x and y, we want to write our ordered pair in alphabetical order. Okay, so our answer here would be 6, 5. Or we would just say our two, because they're asking just for two numbers. They're not necessarily asking for a point. So our answer would just be the first number is 6, the second number is 5. Okay. Let's move on. Sarah and Ash are selling fruit for a school fundraiser. Sarah sold 3 small boxes of oranges and 4 large boxes of oranges for a total of $63. So let's just identify Sarah's equation first. Sarah sold 3 small boxes of oranges and 3 large boxes. So I want to represent that I am differentiating between big and small boxes. So I'm going to label my variables so it's very clear and I don't forget. For small boxes, I'm going to use the variable S. So S will equal small boxes. And then for the large boxes, I don't want to use L because that can often look like a 1. So I'm going to use B for big or large boxes. All right, so now that I have that identified, let's write our equation. So Sarah, she sold 3 small boxes, so that's 3S, and 4 large boxes for a total of $63. Now, Ash was also selling. He sold 1 small box, so that's just S, and 4 large boxes of oranges for a total of 45. Now, for this system, I could eliminate, but I'm going to use substitution this time because I see that S is already almost alone, almost isolated. So we're going to use substitution and subtract 4B from Ash's sales so that S equals 45 minus 4B. Now we can take that and plug it in for S. So 3 times 45 minus, what did I write here? 45 minus 4B. There we go. Minus 4B plus 4B equals 63. Okay, so now we've set up our equation. S equals 45 minus 4B. We've plugged in that 45 minus 4B. So now let's multiply because we have to distribute. So 3 times 45, our first product is 135 minus 12B plus 4B equals 63. Now we're going to combine like terms. So 135 minus 8B equals 63. Now I'm going to subtract 135 from 63 and I get negative. Subtract that, bring down the negative 8B, and I get negative 72. Now, negative 8B equals negative 72, so let's divide by negative 8. I'm running out of space, so I'm just going to write it like that. Negative 8, and that equals positive 9. So B equals 9. And then let's take that and plug the B in for Ash's equation. So S plus 4B equals 45. S plus 4 times 9 equals 45. S plus 36 equals 45. And then if we subtract 45 minus 36, so subtract that on both sides, we'll get S alone. So S equals 45 minus 36, which is 9. 45 minus 36 is 9. So let's just check this to make sure. So I'm going to take Sarah. So Sarah's small boxes were $9. And then her large boxes were also $9. That seems a little suspicious. So 3 times 9 is 27. And 4 times 9 is 36. So we have to see 36 plus 27 is 63. So 63 equals 63. So it looks like our small boxes are $9 and our large boxes are also $9. Interesting. So you'll notice sometimes we get some weird answers that maybe don't necessarily make sense in real life because, you know, that's quite a deal. They're the same price for small and large, but we don't want to just cast it aside and throw it off because we think it's a weird answer. So our small boxes are $9 and our large boxes are also $9. So it's a better deal to get a large box of oranges. All right, and let's move on to the last equation, or the last problem. Liam is selling tickets to the annual Oxbridge Talent Show. On the first day of ticket sales, Liam sold 8 adult tickets plus 2 child tickets for a total of $86. The school took in $107 on the second day by selling 8 adult tickets and 5 child's tickets. So that produced $107. What is the price of each one or price each of 1 adult and 1 child ticket? Now, when we've written out our 2 equations based on the info they gave us, I can see that I've set myself up pretty nicely for elimination. So I'm going to notice that they're both the same sign. They're both positive 8s. So I'm going to need to subtract this time to eliminate. So 8 minus 8 cancels out. 2 minus 5 is negative 3c equals, and then we have 86 minus 107. So 86 minus 107, we get negative 21. And we divide by negative 3, and we get C equals 7. So a child's ticket is $7. Then we now know the child's price, so let's take one of our other equations. Let's take 8 adult tickets plus 2 child's tickets. That equals $86. So 8a plus 14 equals 86. We're going to subtract 14, and we get 8a equals 6 minus 4 is 2, 8 minus 1 is 7. So 8a equals 72. Divide by 8. So an adult ticket is $9. Adult is $9. So a child's ticket would be $7, an adult ticket is $9. All right, guys, that is the end of our review. I hope you guys have enjoyed it. Because this is just a mid-chapter quiz, we won't be having a bonus question on this video, but by watching it, you have set yourself up for success. So good luck. Try to do your study guide today so that if you have trouble, you can come see me in the Math Center before the quiz. Good luck studying, and I will see you in class. Bye.